Let me get my chat running. Okay. Hi guys. Hopefully y'all are still doing okay in, day blubbery boo of our lovely little, quarantine and all that good kind of stuff. So we're going to be doing chapter 9 tonight. Now this is another chapter that we do slightly out of order. We're going to start with 9.1. Okay, so we will start at the beginning. Then we're going to bump over to section 9.4. Okay, and then we're going to back up to section 9.3. We don't actually have to cover section 9.2 for this one. So again, we're going to do 9.1, 9.4, and then 9.3. And the concept with this is kind of what we saw back over in chapter 8 when we were doing confidence intervals. We're going to be using those same two charts, okay, the regular normal bell curve chart. We're also going to be using that t-distribution chart. And so the concept there again is dependent upon what information that they're doing for us. One of them is we do proportions, and the other one is we do mean again, depending upon which parameter we're wanting to look at. That is going to help us decide which chart that we're going to be needing to look at when we're looking at this stuff. Okay, and so that is one of the reasons for the out of orderness, is so that we can kind of go to one chart first and then track into the other chart. The other thing is that I am planning on doing chapter 4 on Thursday at 5 o'clock. I'm trying to keep these at 5 o'clock for everybody. And again, I'm getting them up on YouTube, and then I'm trying to link those over into Canvas and all that good kind of stuff. So that's where we are right now. So I'm going to go ahead and switch over to my whiteboard just so that y'all can kind of pull this stuff, and I'm going to kind of talk us through some stuff. Now, what we're going to be talking about tonight is what's called hypothesis testing. And the basic idea for hypothesis testing is very, very similar to, you'll hear me reference to it a lot as being put on trial, okay, like court of law type of trial. And so basically kind of the parallels that are going to be run with this is, in a court of law, you are assumed innocent until there is enough evidence brought forward that you are found guilty, or that the jury changes their mind. Because again, the jury or the judge, whoever's going to be making this decision, they start out with, you are innocent, okay? You are not, well, let me say this, you are not guilty, okay? And then evidence is presented, and then they have to make a decision as to whether or not enough evidence was shown to change their mind from not guilty to guilty, okay? Now then, when we look at this, there are a couple of different methods that can be used, and again, I'll kind of parallel them with the court system, the court case type of idea, as we're processing through, so that hopefully this will all kind of make sense, okay? Now, when we talk about hypothesis testing, there are two hypotheses, okay? There is what's called the null hypothesis, okay? And the null hypothesis is basically one that means no change from what is stated, okay? This is the idea of not guilty, okay? The idea that you start not guilty and then you move forward. Now, notationally, what we use is H naught. Okay. The other thing is that in a null hypothesis, you are going to have some sort of a parameter equal to some value. Okay. You're going to have some sort of an equal sign running around in this. Now, the other one is called the alternative or the alternate hypothesis. Okay. Notationally, this one is H1. Sometimes you may see this called HA, okay? So if I accidentally put HA, please know that those are the same thing. Also, the O, the 1, or the A, and again, I'll try and stick with the 1 since that's what this text uses, are subscripted. So they're written a little bit lower, okay? Now, this is going to be that our parameter, okay? Now, it may be greater than the value. It could be less than the value, or it could be not equal to the value. Okay. Now, each one of these presents its own unique situation. Okay. And we do have to kind of know which type of test that there is. Okay. So we're going to take each one of these kind of one by one. Okay. So I'm going to clear all this for a second. Okay, so what happens is, and I'm going to do these in their partner pairing so that you can kind of see all this stuff together, okay? So if we have that H naught is a parameter is equal to a value, and H1, or the alternative, is that the parameter is not equal to the value, okay? Trying to make this where it's a little bit straighter. This is what's called a two-tailed test. Okay, and the concept here is we're saying against a number line, we're saying this is what we believe the value is. Now, if they show me enough evidence, okay, to show maybe it's up here or maybe it's down here, okay, then there's all they have to do is provide enough evidence to show that maybe it's higher or maybe it's lower. It could go either direction. I don't know, okay, and we're not real sure which way it's going to go. So because there's two options, this is called a two-tailed test, okay? Now, another type, okay, is, let me erase just a little bit of this, okay, is that this is going to be less than somebody. Now, with this, okay, sometimes you may see this symbol then done as greater than or equal to. Let me move this up, okay? Sometimes they'll do just the equal sign. Sometimes when they go to this less than here, this other one goes to greater than or equal to. These two are kind of interchangeable, but this is what holds true, okay? Now, for this one, if we look on a number line, this is what we believe. The only way you're going to make me change my mind is if you give me enough evidence to bring that answer down here, okay? So example of this might be, I believe the average gas price in America right now is $2.15, okay? Now, if I can bring enough evidence to show that it's actually less than $2.15, and guys, if you've been out to look at gas prices recently, I've seen stuff down in like $1.55, $1.60 range, okay? So if I can bring enough evidence up to show that it is lower than that $2.15 price, okay, then I've met the qualifications for this H1, okay? Now, because of where this area is, this shaded region, it is on the left-hand side. This is called a left-tailed test, okay? So it's called a left-tailed test. Now, we have one other type, okay, kind of dealing with, okay, and that is going to be that this goes greater. And again, if this is greater, this other symbol could be written as less than or equal to. Just know that sometimes they do the equal sign. It kind of depends on the textbook. It kind of depends on the person, okay? That's not as super critical as what we're seeing down here in the bottom edge. So again, looking at a drawing here, okay, this is where we believe the value to be. The only way you're going to change my mind is if you get enough stuff to show me that that answer is actually higher than the value that you told me, okay? So this area is on the right side, so this is what's called a right-tailed test, okay, when we're going through this, okay? Now, the way that this is done, okay, kind of just walking through the process and not getting into the specifics of how we're going to make these decisions, okay, because we are not there yet, okay? We will be shortly, but not right yet, okay? What's going to happen here is when we go through, okay, we have H naught. And keep in mind, okay, the same way that someone is presumed or assumed not guilty in a court of law, H naught, whatever statement they make in H naught, that is what you assume to be true until you prove otherwise, okay? Now, H1 has to be proven, okay? So you've got to find enough evidence to prove that I should change my mind, okay, from H naught to H1. Now, with that being said, the way that the statements, when we get done and we get down to the end of this, the way that they're going to state this is you will either say reject the null, okay, or reject the null hypothesis, okay? And this is basically when you say this, you're saying I'm getting rid of H naught and I'm going to H1. This is similar, okay? This would be very similar to finding somebody guilty, okay? Because you are rejecting their innocence, okay? So if you reject the null, this would be kind of the equivalent of finding somebody guilty in a court of law because you're rejecting your innocence. Or you will fail to reject the null hypothesis. Okay? And with that, okay, this is basically you're saying there wasn't enough evidence to change my mind. Now, this is very, very similar, okay? This is you find not guilty in a court of law. Okay, now, one of the things that happens here though, okay, is, and thinking about this court of law thing, guys, it is possible, okay, in a court of law, that a person is found not guilty on the sole standpoint of there was not enough evidence presented to convict them, okay? And it is not the court's job, okay, to make statements like they are found innocent. That statement, found innocent, is never put forth in a court of law, okay? The jury does not come back and say, we found the defendant innocent. No, they come back and say, we found the defendant not guilty, okay? So the choices are not guilty, they remained not guilty, or there was enough evidence to change their mind to guilty, okay? There is the court's job is not to determine innocence. It is only there to determine whether or not there is enough evidence to move them into proven guilty, okay? So now then, if we take a look, okay, at a couple of example problems over on our packet. Okay, sorry, my brain was having a moment there. Okay. The first one asks, determine whether the alternative statement is left-tailed, right-tailed, or two-tailed. So they state H naught is mu equals 39. Okay, so they're checking on, this is our parameter. Okay, remember parameters are on population things, and population usually has Greek letters. They state that H1 is that mu is not equal to 39. Okay, guys, as soon as we see this not equals 2, okay, that automatically means two-tailed. Okay, not equals 2 means two-tailed, because I don't know whether it's above or below. Okay, now looking at another one. Okay, we've got mu is equal to 39, mu is less than 39. Think about when this is going to happen. This is only going to happen when I find a value that is less than 39. Less than values are over to the left. So this is a left-tailed test. Okay. Now then, going back into our PowerPoint, okay, sometimes the court gets it wrong, okay? When we talk about court cases, there are instances where people are wrongfully convicted, okay? They did not actually commit the crime, but there was enough evidence there, okay, that they were, the jury or the judge thought that they did it, so they had wrongful imprisonment. We see a lot of these cases where my thinking back through like history stuff, times when DNA testing was not available, so all they did was check based on like blood type. Okay, so if the person who committed the crime was type A and the person they arrested was also type A, then that was deemed as something that could help prove that they were the one who did it. You fast forward, and maybe they had, they re-looked at the case and they did DNA testing. It was found out that they actually didn't do it, so that person had been wrongfully convicted. Now, we also have the other side of that, which is going to be that some people get away with it, okay? There's just not enough evidence to pin it to them. And so we have that these are the two types of errors. So, putting this in ideas, okay? Sorry. Okay. If H naught is true, okay, but we reject by mistake, okay, then we have a type 1 error. Okay, now in terms of a court case, okay, remember H naught is not guilty. Okay, so if the person is not guilty, but we reject that, we find them guilty by mistake, we made a type 1 error. This is your wrongful conviction. Okay, so that is a wrongful conviction. Now, if H naught is false, okay, which means they are in fact guilty, okay, but we do not reject, okay, because if it was false, then we should have rejected, but we do not reject, okay. This is what's called a type, and they do this way, error. Sometimes you may see this done in kind of Roman numeral style, okay. This is got away with it, okay. So if we talk about, okay, now we certainly have kind of the two other scenarios. If H naught is true, so they were not guilty, and we did not reject, which means we kept it, then we did the right thing. Okay. If H naught is false, meaning they were guilty, and we rejected it, so we got rid of it because it was false, then we made the right decision. Okay. So we've got type 1 and type 2 error. Okay. So now, taking a look at another couple of examples. Okay. Out of our packet here, we've got, they were checking on H naught is that mu is 41. The alternative is that mu is greater than 41. They came back and figured out that the true value is 41 and H naught is not rejected. Okay, now this reads kind of weird. Okay, so if it says if H naught is not rejected, that means we kept it. Okay, so I'm going to circle it because we kept it. The true value is 41. That's what we were supposed to do. This is a correct decision. Okay. Now then, we've got okay. Now they're wanting us to do that mu is 40. The alternative is that mu is not 40. Okay, sorry, that should be H1. Okay. Now then, here's what they tell us. The true value is 40. H naught is rejected. Okay. Now, with H naught being rejected, that says this is the decision we made. But this is the correct decision. This is not right. Okay. So now, looking at this, thinking about it in the court case, this is they were found guilty, because that's what this is. This is they were found guilty when they weren't. Okay. So this is a wrongful conviction. This is a type 1 error. Okay, this is a type 1 error. Okay, now, the next couple that we're going to look at is the word probleming for stuff like this. Okay, so the next one, number 5, says a new fertilizer is being tested on a plot of land in an orange grove to see whether it increases the amount of fruit produced. The mean number of pounds of fruit on the plot of land with the old fertilizer was 419. Okay, so first off, we know we're checking against the average amount was 419. Okay, and then they made the statement to see whether or not it increases the amount of fruit. So they're trying to figure out or prove that it actually goes higher than 419. Okay, so this is our null. Which part to go over? The type 1 error problem? Okay. Okay, so this is what this would ask for, okay? It just wants you to write down the null and the alternative. Okay, so let's go back to the other one, okay? So I'm just going to write down what we had. Okay, so now the true value is 40. Okay, now let me try this with a little bit different notation. Okay, so I'm going to bring this down. Now, if H naught is rejected, it's gone. Okay, You cannot, that is your decision, is that is gone. If this is gone, you have to go with this decision. Okay, so this is, you're deciding that mu is not equal to 40. Now, when we look back though, it says the real value of the number is 40. But wait a minute, that was this statement up here. That says H naught was the correct response. I should have kept H naught. So since I should have kept this, but I got rid of it, I messed up. Okay, so that means automatically I'm in a type 1 or a type 2. Now, I've got to decide which one it is. Is it type 1 or type 2? Now, going back, type 1 is what I said was the wrongful conviction. Okay. Type 2 is got away with it. Okay. So the question is, did they get away with it? So thinking, this is not guilty, this is guilty. Nope, I found them guilty. I got rid of the not guilty and said they were guilty. That means I said they were guilty when they weren't. Okay. So when you talk about H naught is rejected, draw a line through H naught because that's what you're saying you're getting rid of. Okay. If you do not, if you fail to reject, okay, then you can cross out the other one. Okay. Does that help a little bit? Hopefully it does. Okay, so an example of a type 2. So using the same stuff, okay, if they said something like, so let me rewrite right here. We'll use this one, okay? Using the one, this is just the numbers from number 5, okay? So this is, they would say something like the true value is 419. H naught let's see. Wait a minute. Nope, I just did that the wrong way. Okay. True value is, let's say, 421. H naught is not rejected. Okay, so if H naught, again, I'm going to do this in a color. So if H naught is not rejected, means I'm going to clear this out. So since it's not rejected, I kept it. So we're going to keep that this is it. But it says the true value is 421. That means 421 is bigger than 419. Okay. So this is this statement down here. This is the answer I should have gone with, but I marked it off. Okay. So therefore, I kept their innocence. Okay. So basically this, remember, this is not guilty. So I've found them not guilty when I should have convicted them. Okay. So this is, I should have convicted them because there's where the answer is, but I didn't. Okay. So that would be a type 2. So remember that type 2 is got away with it. Okay. So if they got away with it, then I didn't find them guilty. I did not find them guilty because I crossed out this bottom one. But that check mark says that I should have found them guilty. So the check mark is saying what I should have done. The purple line or the cross out is what I did. If I cross out on the check mark, then I messed up. Okay. And then I've got to decide whether or not which one I did. So in this case, because I did not find them guilty, okay, or I did not reject, that says that they got away with it. So that would be a type 2. Hopefully that clarifies a little bit on a type 2 error, okay? Now then, taking a look at number 6, okay, and hopefully this will all, right now they're really kind of throwing a lot of parts and pieces at you. It actually kind of flows a little better once we actually get into the process of what we're doing, okay? So it says, a restaurant owner, this is number 6, a restaurant owner claims that the mean amount spent by diners at his restaurants is more than $30, okay? Guys, it said is more than $30. That means I'm actually going to use that statement to help me write that alternative, which means this, oh, sorry, no, equals. Okay, so depending upon how they write the statement, okay, sometimes the way they word stuff will help you write that original null hypothesis. Sometimes it helps you write the alternative one, okay? You just have to read carefully and make sure. With this though, the alternative hypothesis is always going to be something like more than, less than, or not equal to, or not the same as, or a different value. They'll do something like that. The alternative, or sorry, the null hypothesis is always going to be an equal to statement, okay, when they do this. Now then, it says, null is not rejected, okay? Now, what this means is, and they want you to understand how this is now worded, okay? So if the null is not rejected, that means I'm going to hang on to it, so I'm going to get rid of the other one. So null is not rejected. That means I did not get rid of it, so we're going to get rid of the other one, okay? So now, again, going back to a court of law, okay, type of idea, basically what this is that they didn't find enough information, they didn't find enough evidence for us to change our minds. So there is not enough evidence to conclude the mean amount spent is more than $30, okay? And guys, there's certainly different ways that this can be worded. I have seen these worded where they do until further evidence is provided, the mean amount is not more than $30. There is insufficient evidence to conclude. So they can do different types of phrasing. The idea here is if you do not reject, there was not enough there to change our mind. Okay, is the big overarching premise for this whole thing. Okay, now if we had rejected, okay, if they had said the null is rejected, then we would say there is enough evidence to conclude, okay? So if we reject, which means we got rid of H naught, so we would have crossed this out, and we would have had H1, so we did reject it, then we would have said there is enough evidence, okay? Again, not guilty, guilty. There's enough evidence when you find somebody guilty, okay? And again, you're going to hear me reference a lot of stuff over to this court of law type of thing because it's the most applicable real life situation that most people are going to be familiar with, that they can kind of wrap their head around. That is the comparison, okay? So that is the end of 9.1. So we're going to go ahead and move over into 9.4, okay? And so what we're going to do in 9.4, now 9.4 and 9.3, which we're going to do after this, okay, again, this chapter is out of order. In 9.4, we're going to be doing hypothesis testing on a population proportion, okay? So P, okay, if you remember back when we were doing confidence intervals last week, we used the letter P. That is going to be coming back, okay? So a couple of things here that we are going to be looking at. P is our population proportion. X is the number of individuals. N is your sample size. P hat, which we saw before, is our sample proportion, which is X over N. Okay, so for helpful little things with that. Okay, now, there are two methods, okay, for doing this, okay? And this is, it doesn't matter whether we're doing proportion or the other one we're going to be doing mean. There are two styles of how to do this. Most of the time students pick one style or the other, okay? And I do not care which one that you use. So I'm going to explain both, and then as we get into the methods, as we get into the examples, I'll make sure to work some with each styling, okay? Now, there are a couple of assumptions that are made that need to happen here, okay? Number one is, so these are assumptions, okay? One is we have a simple random sample. Okay. Two is population at least 20 times larger. Okay. Third is two categories. Basically, they either have whatever it is we're looking at or they don't. And four is N P naught and N1 minus P naught I think this is, hang on. I'm checking something. Yeah. Or at least 10. Okay. Now, this P naught thing that they're talking about here, this is going to be the P value that is in the null hypothesis. Okay. So, and again, I'm going to talk us through this and make sure that we understand what's going on here. Okay. So, looking at a couple of example problems real quick before we actually get into process, so that you understand where stuff is going, okay? As we're going through, okay? So it says we've got a sample size of 58. There were 36 individuals that had whatever it was that we were looking at. They want us to estimate P hat, okay? Now guys, this is N, that's X. So remember, this is X over N. So this is 36 divided by 58. And I have that is 0.621. And that is rounded at 3 decimal places, okay? Now, the second thing asks, do we meet all of our assumptions? Okay, so assumptions met. Okay, so it says in the setup for this, it says simple random. So check for the first one. Second one is the population is at least 20 times larger at 58 for a sample size. If we're talking about the US or anything like that, we're going to be 20 times larger. Third, was that it's two categories, okay? We have 36 had whatever it was, then the other group is going to be not. And then the fourth one was in P not, okay? And in this case, we are good for this one. This one is going to come up a little bit more the further along we go. We don't actually have a P naught for this, okay? But we're going to go with yes for right now, and as we move forward into physical examples, we'll make sure to check for this stuff. Okay, now then, let me talk about how these tests are going to be done, okay? So there are two approaches, okay? And I don't care which one you pick, okay? It really doesn't matter to me. There is the first method is called the classical approach, or one of the methods. I'm not going to say the first. This is the classical approach. Okay, so I'm going to this up. Okay, now here is the idea with the classical approach. The classical approach says, here's my line, and I'm drawing a line in the sand. Okay, and I'm going to start here. Okay, so thinking about back to that court of law. Okay, here is my little person that I'm putting on trial. Now, in order for me to find, now here is when I will find them guilty. Okay, now for me, okay, and let's put somebody on trial for, I don't know, murder. Okay, things that have to happen down here. Okay, I have to have a victim. Okay, I need to have a weapon. Okay, I need to have a motive, and I need to have a tie to the weapon. Okay, so for me to convict this person or find them guilty, I have to have a victim, I got to have a weapon, I got to have a motive, and I have to have some way to tie this person to the weapon, whether that is DNA, fingerprints, whatever else. Okay, so let's put this person on trial. Let's move them on trial. Okay, so find a victim. Okay, I'm moving them this direction. I have a victim. Okay, we've got a weapon. Okay, let's go. They give me a motive. Okay, so maybe this is we found the victim. They were found stabbed. Okay, and we found the knife that they were stabbed with. Okay, we've got a motive. This person and the victim were arguing over money, over a large sum of money. So I got a motive. They were, they had maybe some people heard them fighting about money the day before, something like that. Okay, so I've got people who saw them fighting, okay, over, saw them or heard them arguing over money the day before. I know that they now let's go with the weapon was found with the victim. Okay, and maybe I've got that this person, they bought some rope at a hardware store, and they bought some tarp at a hardware store. Now that certainly moves me a little more, okay, but I don't actually have the tie-in to the weapon yet. Okay, so I have to have these four things in order for me to find them guilty. I can't convict them, okay, because I cannot put that knife in that person's hand, okay, whether it was wiped clean or there wasn't any blood or whatever else. So if this is the scenario, I'm going to find them not guilty, okay, because they did not cross over the line into that guilty region. Okay, now let's reset. Okay, now we put somebody on trial again. Okay, I've got a victim. Okay, so that moves me closer to the line. I've got a weapon. I've got the knife that they were stabbed with. Okay, I've got motive. They were arguing about money. I have got fingerprints of this person and this person's blood on this knife. Okay, well, I just got them there. Now then, I've got people that heard them arguing about money. I've got that they bought rope and stuff. I've got 15 people who saw this person take the body down to the wherever they dumped it off of. Okay, guys, it doesn't matter how much farther this goes. Once I'm past the line, I'm finding them guilty. Okay, it doesn't matter whether it is this amount or that amount. Okay, it does not matter. Once I'm at the line for guilty, I'm finding them guilty, period. Okay, so that's the classical approach. Now, the other approach is what's called the p-value approach. Okay, now with the p-value approach, here's a person. Now, this person was already convicted, okay? And somehow we had an innocence meter, basically, okay? And so what happens is they set an innocence amount at, I don't know, 10%, okay? So this person was convicted, okay, of murder. And it was when their innocence meter got down to 10%, and again, they would have started at 100, okay, because they started out not guilty. When their innocence level, they were found guilty at 10%, okay? So now, here's our new trial. Here's this person. Here's their innocence meter, okay? Now, they start off with 100%, okay? Now, put a mark down here. Here's the idea. If this person gets down to 10% or lower, I'm going to convict them because I've already convicted somebody at 10%. So if this person gets to 10% or under, then I'm going to convict them, okay? So they start showing me stuff. They start showing me the victim, and they start showing me the motive, and they start showing me the weapon, okay? And we get down to like here. Now, I don't know if you can see this real close, okay? But there is my mark, okay, at 10%, and I still have some innocence above that, okay? So let's say that their innocence level was here, and that was at 12%. At 12%, they're not guilty, okay? Because I will not convict them if they did not get under this level over here. So at 12%, they're not guilty. Now, if over here, I get them down to here, okay? And let's say this is like 7%. At 7%, I'm going to find them guilty, okay? So the idea here is they are going to give you some pre-assigned level, okay? And you are going to be finding this. This value is your p-value, okay? This level of innocence that is left, okay? If the p-value is lower than this indicated value, then you're going to find them guilty, okay? Remember that in our other terming, that was reject the null, okay? Okay, so if the p-value is lower, then you will reject the null. If the p-value is higher, so back when I was at that 12% and I said they were not guilty, then that is fail to reject, okay? So now then, in either scenario, okay, in either one of these approaches, okay, we are going to have to find what is called a critical value, okay? So we're going to need to a test statistic. Okay, now the formula for our test statistic is p hat minus p naught over square root p naught 1 minus p naught over n. Okay, so this is the formula for your test statistic. Okay, and in either scenario, you are going to have to find this. Okay, so for example, it says if we have, so here's an example of this loveliness. Okay, it says we've got h naught is that P is 0.7. H1 is that P is not equal to 0.7. Okay. Now then, this is still working off of the first one. Okay. Let's see. Okay, so if I'm going to find this, okay, now keep in mind we had that P hat was 0.621. Okay, so plugging this in, I've got 0.621 minus 0.7 over square root 0.7, 1 minus 0.7 over 58. Okay, so this is going to be 0.621 minus 0.7 is going to be negative 0.079 over, now 0.7 times 1 minus 0.7 divided by 58 is going to be 0.03, no, sorry, 0.0036 dot, 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 okay? So I've got negative 0.079 divided by, into the square root of that, 0.06017. Okay, and we end up with negative 1.31. Okay. Okay. Now then, this is our test statistic. Okay, so I'm going to mark this up here. Okay, now let me talk to you, okay, about how this critical value is going to work. Okay, so now let's talk. We had P is equal to 0.7. And we had P is not equal to 0.7. And we know that this is a two-tailed test, okay? Now, the way that this works is we're going to be working on our bell curve, okay? And on a two-tailed test, okay, and this is the classical approach is what I'm going to talk about here for just a second, okay? Now, with the classical approach, what's going to happen here is I need to know the values for these two lines. Now, the other thing that they are going to set up is they're going to set up what's called an alpha, okay? The alpha in this case that we're going to look at is 0.01, okay? This is kind of like that innocence level type of idea, okay? Now, what we need to do is alpha has to be the amount of the shaded region. So this and this total is 0.01. Now, if we go over to the charts, okay, one of the things, okay, that they have down here in this bottom little corner for us, okay, let me get this up here so you guys can see, okay, this is our hypothesis testing chart, okay, and so they have alpha here is 0.10, 0.05, or 0.01. Okay, these are the three most common. If it's not one of these three, okay, then we'll talk about how to do this. Now, they also have left-tailed, right-tailed, and two-tailed, okay? So now then, with this, okay, we were using 0.01, and we said we were on a two-tailed test. So this is 2.575, and it is the positive and the negative, okay? So coming back to our picture, okay, what that means is this number is 2.575. This is negative 2.575 on our picture. Now then, what we then do is we take this, let me switch to a color that works up better, okay? This critical value, okay? And we know it's two-tailed because of the not equal sign. Not equals is automatically two-tailed testing, okay? We then put this number in this chart, okay? So knowing where negative 2.75 is, here is negative 1.31, okay? Anything in the shaded region is reject. That is like your guilty region. Anything in the non-shaded region is your fail to reject, okay? So in this case, we will fail to reject. Okay, so now let's do one of these from top to bottom, okay? Kind of processing all the way through as this goes in, okay? So, okay, so from top to bottom. Okay, we have got, okay, a researcher reported, that 71.8% sorry guys, I'm reading something. Okay. Of all emails sent in a recent month was spam. A system manager at a large corporation believes that the percentage at his company may be 70%. Okay. So he is wanting to say, okay, that the proportion is 70%. Okay. He examines a random sample of 500 emails received at an email server and finds that 373 of them are spam. Can you conclude that greater than 70% are spam? So we're trying to show that greater than 70%. Okay. Now I'm going to do this with the classical approach just so that we can go ahead and process. Okay. So now then, they tell us to do alpha is 0.10. They're also going to ask us to do alpha is 0.01, okay? Now, I'm going to start with the 0.10 version, okay? So this is what we're going to do. So first thing, before I do anything else, is I'm going to get me a pretty little picture, okay? They want my proportion to be greater. My greater than stuff is going to be up here, okay? Greater than is higher. So what that now tells me is that this is a right-tailed test, because I'm up here in the right end, okay? Now, I want to go ahead and find that critical value. So again, I'm going to go back to my chart. Tell me out. Now, you could do this by working backwards out of your chart. We know that this area up here has to be 0.10. So you would look in the body of your chart, okay? So in the 4-digit numbers in the body of your chart for as close to 0.9000 as you could possibly get. Now, they have done the math for us though. So coming down here, our level of significance or our alpha is 0.10, which is this top one. And we are on a right-tailed test. So this is 1.28, okay? So our critical value is going to be at 1.28 for this one, okay? And again, I'm doing, let me switch this color out to alpha is 0.01 so that we can do that in, so that you'll know when I change colors. When I change colors, I change ones, okay? Now, the next thing that I need to do is I need to find a couple of values, okay? So p hat is going to be 373 divided by 500. And that is going to be 0.746. Okay? So now, finding our test statistic, okay, we're going to do 0.746 minus 0.70 over square root 0.70, 1 minus 0.70 over 500. Okay, so we get 0.046 and this number on the bottom is 0.020493 dot dot dot. And this gives me a value of 2.24 is what we'll call it. Okay. Now then, I'm going to put this color, this mark in blue. So looking at where we are up here, guys, this mark is at 1.28. Okay. 2.24 is going to be over here. Okay. So here is 2.24. We are in the dark shaded region. That is reject. Okay. So when alpha is 0.10, we reject the null. Okay. So we reject the null. Now then, if they ask us to do the alpha 0.01, so I'm going to draw my picture. This time I'm going to do it in this pink color. Okay. Hopefully y'all can still kind of see this. Okay. And if I pull my chart, I'll pull this down here again. If I use the 0.01 level on a right-tailed test, we're at 2.33. Okay. So this time when I draw my line, we are at 2.33. And that's going to be where I do my shade out here. Sorry. Okay. Trying to keep all of this together. Okay. So now, where is our 2.24 number? 2.24 is here. Okay. So it's in front of. So if alpha is 0.01, we are not in our reject region, so we fail to reject. Okay, so again, this would have been two separate tests. Normally, you will only be asked to do one of these, okay? Normally, you would only be asked to do one of these and not the other, okay? You would not be asked to do both. Okay. So let's look at another one. Okay. So it says a news poll conducted in 2012 asked a random sample of 1,268 adults. I'm just going to make some notes here. N is 1268. Okay. In the United States, how much confidence they had in banks and other financial institutions. A total of 144 said that they had a great deal of confidence. An economist claims that less than 11%. Okay, so This is going to help us write our null and alternative. So he thinks the proportion is less than 11%. That means this is 11%. Okay. Can we conclude the economist's claim is true? So basically, the only way we can do this is if we have down here. Now, we're still going to make this as reject or fail to reject when we make our statements. They want us to use alpha is 0.05 and alpha is 0.10. Okay, these are the two that they ask us to use. Okay, so now pulling some information. First off, p hat is 144 over 1268. This is 0.114 is what I'm going to call it. Okay. Actually, I'll let this run a little bit. 3, 5, 6. Okay, we'll run it out to there. Okay. Now, ideally, you want to let this run as far as you can. Okay. When all of this is processed through. Now, let's get a picture in our head of what we're looking at. Okay. They want us to do less than. Guys, less than is down here on the left side. So we are in left-tailed. Okay. Now, working on a critical value. We're going to be working on our 5% rate. So I'm going to zoom down here to our pretty little chart. Okay, so significance level is going to be 0.05. Sorry, hopefully it'll catch up to me here in just a second. Okay, and we are on a left-tailed test. There we go. It's at negative 1.645. Okay, so I'm going to go ahead and go mark that. Okay, so now the next thing we need to do is we need to find our test statistic. Okay, oops, sorry. See if I can clean that up a little bit. Okay, so 0.11356 minus 0.11 over square root 0.111 minus 0.11 over 1268. We're at 0.00356 divided by 0.00878, so on. So doing that division, I get 0.41. Okay. So I'm going to pick a color here. Oops, sorry. Out of screen. 0.41. So now looking, okay, the center of this chart is 0, by the way. 0.41 is going to be right about here. Okay. So when alpha is 0.05, we're going to fail to reject. Okay, because we're up here in our non-shaded region for that. Okay. Now then, if, okay, we go to our alpha, I'll switch into that other color, and I'll draw my pretty shape here. Okay. For 0.10, this value is negative 1.28. Okay, trying to get this all on the same slide. Negative 1.28. Now, again, putting our mark on here, that's 0. That's 0.41 right there. If alpha is 0.10, we're still on fail to reject. Okay, we're still on a fail to reject setup for that one. Okay. So hopefully that kind of makes a little bit, you can kind of track with that. Now, again, the next thing that I'm going to show you, okay, so this has all been classical approach. Now what we're going to look at is our p-value approach to this. You are not, for me, required to do both, okay? Now, on homework, you may be asked to do both, okay? You may be asked to do a problem with the classical approach. You may be asked to do a problem with the p-value approach, just to show that you understand the concepts from those, okay? But for me, pick whichever one you like better, okay? Now, we are still going to see, okay, some of the same math done in both, okay? So now, here is the way that this works, okay? So looking at an example for this, okay, we've got in a survey of 144 smokers. Okay, so let me find where I'm at here. Okay. In a survey of 444 smokers, we've got 187 of them reported that they had used a nicotine patch to try and quit smoking. Can you conclude that less than half of the smokers used the nicotine patch? Okay, so they want to know if this is less than half, which is going to be 0.50. Okay, so this means that it's equal to 0.50. Again, the null hypothesis is always going to be an equal sign. Okay, now, next thing is I am going to go ahead and find p hat. Okay, and this is going to be 187 over 444. And that is going to be 0.4212. I'll let that go to there. Okay. Now, with this method, okay, now thinking again, less than is to the left. This is a left-tailed problem. Now, we are still going to use the idea of the bell curve here in just a second, okay? But the next thing we're going to do is our test statistic. Okay, so we're going to do 0.4212 minus 0.50 over 0.501 minus 0.50 over 444. We got negative 0.0788 over 0.0237. Okay, we get negative 3.32. Okay, so there's our test statistic. Now, here's what's going to happen with this. The way you now do this is a left-tailed test. You need to find the area to the left of this value. Okay, so on a bell curve chart, okay, so we are now doing, now, if this had been right-tailed, then I would do the area to the right of this, okay? And I am going to do one where there is a two-tailed test because you're going to have to understand how to do it, okay? So, I'm going to bring this over here so that you can see. So, negative, ooh, my lights got really bright there for a second. Let's see if my phone will catch up to me. Let's see if that'll help. Okay, so negative 3.3. And then we're going to go over to 2. So I am at, I don't know if you can see that, 0.0005. Okay, so the p-value is 0.0005. Okay, now then, how do we make our decision? The answer is alpha is 0.05. Okay, the question is, remember, this is your level of innocence. This is an already convicted rate. If this is lower than this, you reject. Okay, if this number is lower than this, you reject. If this number is not lower than this, then you fail to reject. Our p-value is lower, So we're going to reject the null. Okay, so we're going to reject the null. Okay, so I need to stay off that pink. So the pink's getting a little light. Okay. Now then, let's talk about another one. Okay. So we're going to do one of the two-tailed ones, okay, because they are done slightly different. Not that much different, but there's one thing that you have to note of for this, okay? So an article reported that 73% of companies have Twitter accounts. An economist thinks that the percentage is different at technology companies. Okay, so first off, if they say it's different, that just says it's not equal to whatever they said it was. Okay, now then, she samples 70 technology companies and finds that 44 of them have Twitter accounts. Okay, and then the question is, can she conclude this? So 44 divided by 70 is going to be 0.6286. Okay. Now then, because this is a not equals to, this is a two-tailed test. Okay. Again, because it's a not equals to, it's automatically two-tailed. Okay. Now then, we now need to find our test statistic. Okay, so we've got 0.6286 minus 0.73 over 0.73, 1 minus 0.73 over 70. Okay, so this is going to give us 0.6286. Negative 0.1014 over we get negative 1.91. Okay. Now then, if we look in a bell curve, okay, now first off, it's two-tailed test. So if I find the area to the left of negative 1.91, if we look that up in a chart, this side is 0.0281. Okay, now what you have to assume is that the other side, is the same amount. Okay, now what that means is your p-value is both of those together, or 2 times the 0.0281. You have to do this only in the two-tailed test, okay? And this is 0.0562. Okay, now the alpha that they give us is 0.10. So here's the question. Is our p-value lower than this? Okay. And in this case, the p-value is lower. So we reject. Okay. The p-value is lower, so we reject. Okay. Now, let me ask this question. If the p-value had been 0.05, okay, would we reject or fail to reject? So again, we look back. Is the p-value lower than alpha? The answer is no. the p-value is not lower, so we would fail to reject. Okay, now some students prefer the p-value approach because it lines up very similar to when you were finding areas to the left and to the right when we were doing those back over in chapter 7. Okay, if they are equal, you fail to reject because it has to be strictly less than. In order to reject, it will have to be strictly less than. You don't usually get a whole lot that are spot on equal, but the general rule is less. It has to be strictly less than when this is done. Okay. Some people like this p-value approach because it is very, very similar to when we were doing the to the left, to the right. Some people prefer that classical approach because it is a here are my zones. Okay. It's either I am in a reject region or I'm not. Okay. And again, for me, I don't care. Okay. I really do not care which one you like or which one you prefer. That is your personal preference for what's going to happen with that. Okay. So now then, you can use a calculator, okay, to help you do this. Now, with the calculator, it is going to do it strictly under a p-value approach. This is the only option that it will do. And so taking a look, I'm going to go back and do that one where we had the 187. So this is number 5 in our stuff. So where you're going to go for this is you're going to go to stat, and you're going to go over to tests. Okay. And hopefully this will catch back up to me. Okay. And you're going to be picking option 5. Okay. It says 1 prop z-test. Okay. Let me zoom down on this real quick. Okay. 1 prop z-test. That is what we're doing. Again, we're doing proportions here, and we are on a z-test for this. Okay. We're using our z1. Now, with this, okay, you have to give it p0, and going back to the one about the smokers, this was 0.50. You have to give it x, that was 187. You have to give it n, which was 444. And then you have to tell it whether or not you want to be greater than, less than, or not equal to p0, okay? And so we were actually working on less than, so I'm going to calculate this. Okay, so I'm doing less than. And then I'm going to go down to calculate. Okay, and what it is going to tell me, oh, sorry, let me rephrase that. Oh, okay. What it is going to tell me is that the z-value is -3.32. That is our test statistic. Okay, that is your test statistic. And then this next one down, okay, this is the area under the curve. Now, guys, you do have to be careful with this because it says E-4. That means you are backing that decimal point up 3 places. So this would have been 0.0004. The p-value would have been 0.0004 for this, okay? So if you're going to do p-value or test statistic, there you go. Okay, so that's how you do that. And again, that was option number 5 under tests, under stats, and then tests. Okay, so it is possible to do it on a calculator, just so that you have that option available to you. Okay, now then, if we move on into section 4.3, okay, we are going to see very, very similar ideas. Okay, the only things that are going to change is how we calculate our test statistic. Okay, so for section 9.3, the test statistic formula is going to be x bar minus mu sub 0 over s over the square root of n. Okay, so this is how we're going to find our test statistic. Okay, in this one, okay, so it's gonna be different. Now, the other thing is, with this one, okay, guys, I would, where did the 0281 come from? Let me go back and look. Oh, the 0281. When you go onto a bell curve chart, okay, let me back up, Jessica, I got you. Okay, we'll come over here. Whoop. Okay, on that problem that we were working on, the z-score was negative 1 point, oh, let me find it. Where did I put it? Negative 1.91. Okay, so on our chart, we're going to go to negative 1.9 and then over to 1. Hopefully you can kind of see that. There is our 0.028, and then we doubled that because it was a two-tailed test. Okay, so hopefully that clarified that up. Good deal. Okay, now then, with this section, okay, because we're going to have to use our t-distribution chart, the p-value approach becomes a little bit more difficult, okay? I more so encourage the classical approach with this one, but it's not that the p-value can't be done, okay? So now let me explain how we would find p-values for this, because we are going to be using our t-chart for this, okay? So I'm going to get over to our student t-distribution, okay? And so here is the way this works. Okay. Now then, you have to kind of read the chart a little bit backwards for this, okay? I'm going to actually move this over just a little bit so that you can see some stuff a little bit better, okay? Now, what they specify, actually, I'm going to move over one more time. T equals negative 1.65. Okay, and we're doing, all right, so let me show you the setup for this. Okay, they're telling me that T is negative 1.665, N is 21, and we're doing a not equals to, so this is a two-tailed test, okay? Here is how this works. This is kind of a little bit odd when we're doing this in the tables, but I want you to see where this is coming from. So back over here on our lovely, pretty little t-chart, okay? And I'm going to try and get this thing to sync up and fine. It's going to be really difficult. So one of the things that you have to remember is that this table is done on degrees of freedom, okay? If you remember, degrees of freedom is n minus 1. So what we're going to be looking at is line 20 down here, okay? Now, what's going to happen is I need to find, even though it said negative 1.665, we're going to try and find which two numbers that fits between, okay? We don't need the negative. We don't need to deal with the negative part, okay? Just dealing with the positive part. So as I come across on line 20, okay, and I'm trying to hold this really, really steady, we find that 1.665 hits between this 1.325 and this one here at 1.725, okay? So if I trace these back up to the top of the chart, we're between 0.10 and 0.05, okay? Now, what's going to happen with these is, again, it's a two-tailed test, so you got to double them, okay? So you are going to take, for this, okay? The smaller number was 0.05. The larger number was 0.10, okay? And you're going to double, okay? And it's because this is a two-tailed test. If this had been a left or a right-tailed test, you would just take the number, okay? So 0.10 is less than our p-value is less than 0.20. So what this happens is we know that our p-value is between these two numbers. Now, personally, I don't like that there's this range. I don't know if that p-value is 0.11, 0.12, 0.18, 0.17. I don't know what it is, okay? But I'm still supposed to compare it to an alpha, okay? So let's take a look at one more, okay? That is a slight bit different, okay? So for this one, they give us that t is going to be negative 3.107. Again, for the chart, you're not going to need that negative on there for this particular, when they're asking you to do this. So n is going to be equal to 11. H1 is that mu is less than mu naught. Now, with this being less than, that says it is a left-tailed test, okay? That also means that it's only one tail, okay? So again, with n being 11, we're going to come over here to line number 10, okay? And I'm going to try and find 3.107, okay? Or, you know, kind of get in between it. So if I come across, I've got 2.6764 and 3.169, okay? And I am between those two. So looking up to the top of my chart, it's 005 and 01. So coming back across, 0.005 is smaller than my p-value, is less than 0.01, okay? And again, though, I don't know specifically what my p-value is if I'm using my chart for this, okay? Some people do not like that idea, okay, that they don't know specifically what that p-value is when this is happening, okay? Okay, now then, let's talk about how to run one of these. Now, I am going to talk about this starting from the idea of that classical approach, okay? And then pulling from there, okay? And then again, we'll talk about how to do this with the calculator, okay? So we're going to start with a classical approach for this and discuss it from there, okay? So here is what we're going to start. It says, this is number 8, okay? A market research firm reported that the mean earnings of all family practitioners in the United States was $178,258. In a random sample of 60 family practitioners in Los Angeles, they had a mean earnings of X bar, okay, was $191,600 with a standard deviation of 42,137. I'm going to write all that down here in just a second, okay? Does the data provide sufficient evidence to conclude that the mean salary is greater than? Okay, so let's start by writing up our two things. So they're saying that there is a statement that says the mean is 178,258. They're wanting to show whether or not it's greater than 178,258. Okay, now with the classical approach, the first thing I'm going to do is I'm going to go to my bell curve. We're on greater than, so that is a left-tailed test. Okay, now they did, and we have, so now other information that we have. X bar is 191,600. S is 42,137. And alpha they want me to use is 0.10. Okay, so now here's how we do this with a critical value. Okay, So I'm going to pull my chart. I'm going to bring this across. Okay, so on our chart, they want us to use alpha as 0.10. So that means I'm going to go here on my chart. Now then, they said N was 60. So I'm going to go to line 59, if I've got it. Okay, and I don't. Okay, so I'm going to go as close as I can. So I'm going to actually use line 60. 1.296. Okay, so back over here on my pretty picture. That is going to be at 1.296. Okay. Now then, we need to now do our test statistics. So we're going to do this math up here, okay? And I'm going to switch colors when I go to do this, okay? So we're doing X bar, so 191,600 minus 178,258 divided by 42,137 over the square root of 60. Oh, I didn't write that down. N was 60, okay? So now, calculating that, I've got 13342 over. Okay, and I get that this is 2.45. Okay, so now looking at where 2.45 would be, 2.45 would be something like here. Okay, so I'm in a reject region, so we would reject the null. Now what that means is we would get rid of this, and we believe that the mean is actually greater than the 178,258, okay, based on our evidence. Okay, we would say there is enough evidence to reject the null and say that the mean is greater than 178,000. Sorry, there it is. Come back. Than that. Okay. Now then, let's take a look at one of these with the p-value approach. Okay, kind of looking at one of these with a p-value, and then I'll talk about how to put this in on a calculator. Okay. Okay, so I'll keep my test. So it says the mean annual tuition and fees for the 2013-2014 academic school year for a sample of 13 private colleges. So the sample, the average of the samples was $38,500 with a standard deviation of $7,000. Okay. The data shows that it's reasonable to assume that the approximation is normal. Can you conclude that the mean tuition and fees for private institutions in California differs? Okay, so anytime we see the word differs, that means not equals to 35,000. Okay, so right now, because of that not equals, we know we are in two-tailed. And since I'm going to be doing this with p-value, I know that means I'm going to have to double any of the values that come out of our table. Now, they want us to use alpha is 0.10, okay, for this one. Now, I'm still going to, so next thing is we're going to go ahead and find our test statistic. Okay, so we are 38,500 minus 35,000 over 7,000 over the square root of 13. Okay, so 38,500 minus 30 is going to be 3,500 over 1941.45. And this comes out to be 1.803. Okay. Now then, how to do this with the chart and table. Okay, so I'm going to bring our chart and table back across. Now, here we go. N was 13. Sorry, let me get rid of that extra light. Okay, N was 13, so that means we're going to line 12. Okay, now, moving across line 12, we're going to try and find where 1.803 sits. Okay, so 1.803 is going to be between these two, 1.782 and 2.179. Do not confuse this with that 1.083 that's over here. We are 1.803. Okay, so make sure you're watching your values here. Okay, so we're between these two. Now, following those up the chart, okay, it's 025 and 050. Okay, so 025 and 050. Now, remember what that means. Because this is two-tailed, we have to double. So 0.05, p-value 0.10. Now the question is our p-value less than alpha? The answer is yes, okay? Because it says this p-value is less than 0.10. Alpha happens to also be less than 0.10. So therefore, p-value is less. So we reject. Okay. Now, the reason I don't like this as much, okay, if you have stuff where if they pick like a really strange alpha, like 0.08 or something like this, you would have a really hard time doing this by hand for this, okay? It's not that it can't be done, it's just it can't be done using the charts, okay? You would have to go to a calculator to help out with that, okay? Now, speaking of which, let's talk about how to do this on a calculator, okay? Now then, with this one, okay, and I'm going to bring my calculator into frame here, and we are going to do this one that we just talked about, okay? This one that we just did, okay? So stat and over to tests, and we're going to be doing a t-test, okay? So we're going to be doing this second option, option number 2, we're going to be doing a t-test, okay? And we are going to give it stats, okay? So we're going to be giving it its information. If you were given a data set, you would put that data set into L1, and then you could have it pull data. Now, mu naught, that's the one in the null hypothesis, is the 35,000. X bar was our 38,500. The standard deviation was 7,000, and N was 13. Okay, now you do have to decide which one we're doing. We're doing not equals to, so I'm going to make sure that that one's highlighted, and then I'm going to calculate this. Okay, and I'm going to pull this down a little bit so that you can see a little better. Okay, so there is our t statistic. There's that 1.02, and again I rounded to 1.803, so there it is. There's that p-value. It's 0.0965. Guys, that is between 0.05 and 0.10, okay? So there is the actual p-value for that one, okay? So it will give you a p-value and a t or a test statistic, okay? But it is your job on how to use those within, okay? So you could still do this and get a t-value or a test statistic, and then use that to help you decide whether it is in the classical approach. That is fine, you could do that, but it will also give you the p-value for that. So that is the end of chapter 9 as we're going through, okay? Again, if you have any questions, use the Ask My Instructor stuff. inside of that, or message me or email me, and I am getting back to those emails just as fast as I can. I've got a couple that I'm from today that I've got to answer. But I will be answering those just as quickly as I can. And then on Thursday night, we'll be meeting over chapter 4. Chapter 4 is going to, a calculator is going to make life easier for chapter 4. And it is actually not tied into any of this that we're doing in this one, okay? I have not heard anything specific on whether or not we're going back to classes next week. I'm assuming so until they tell us otherwise, okay? If they come out with information that says otherwise, then I will communicate how we're going to do stuff. But for right now, I'm assuming yes, because I haven't seen anything that says we're not. But I am remaining flexible because I know that this is a constantly evolving situation that we're in. So, if there's changes, I will make sure to let you guys know how we're going to accommodate those changes. So with that, that is the end of chapter 9. I hope you guys have a great evening, and I will talk to y'all later.